Hi, everybody. Hopefully you're here because you're interested in, for whatever reason, making connections in mathematics between the slope, the midpoint, and the distance for two coordinate points. So I'm going to show you some connections. Hopefully these will all make sense and you're going to get some shortcuts along the way. So a lot of people are going to be happy about that. Anyway, let's get started with our first example. I was going to do these all at once, but I'm going to make it in 3 parts. So it's going to have part 1, part 2, and part 3. Hopefully you'll stick with it and try all 3 parts. And let's get started. Our first example is right here. If I'm given these 2 points and I want to find the midpoint, the slope, and the distance. So let's go ahead and graph them first. I think a picture is always helpful. So the point 1, 1 is located right here. And the 0.79 is right there. And I may be interested in the line between them. Not sure if I can draw a line with this one. Let's see. Let's try a shape. Let's try a line between here. See if it lets me. Come on. I want to draw a shape. Okay, it looks good. There it is. Okay, so I have a line between these two. And what I might be interested in is the midpoint, the distance, and the slope. The slope, a lot of people understand as how steep this line is, or this line segment rather. This is actually a line segment. If it were a line, it would have arrows on the end and it would continue forever. So a lot of people learned that slope is rise over run. This is how much is this line going up for how much it's going over. If you were thinking about a staircase, the steepness would kind of be described by the slope. So lots of ways of looking at it. And one way to do that is to count from one point to another point. And if I count up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4, 5, 6, sorry, I missed on that one a little bit, we can say that the slope or the steepness of this line can be described as up 8 over 6. And of course, this fraction could be reduced, but I'm not going to reduce it for a very good reason. Now, some people are going to want to do this algebraically, and there's lots of reasons for doing it this way. But the slope formula says that we take y2 minus y1 over x2 minus x1. These little numbers at the bottom are called subscripts. And the reason they appear is because we've got 2 different x's and 2 different y values that are happening here. I've got an x and a y here, but I also have an x and a y here. Well, obviously, we don't want to do this because this would be very confusing. I have 2 different y values and 2 different x values. So what we do is we put a little subscript on here and we say this is our first point and this is our second point so that we can describe it. Now I'm going to go ahead and substitute inside my formula. By the way, my 5-step problem solving process is to get a diagram and label it, then to write a formula, then substitute inside parentheses. The parentheses are generally a good idea in general. In this particular instance, they aren't that important, but I'm going to go ahead and put them anyway. And x2 minus x1, and we get 9 minus 1 is 8, and 7 minus 1 is 6. So the slope of this line could be described as 8 over 6. We can reduce the fraction as 4 over 3, but I have a very good reason for not reducing that fraction. And the reason is because we are going to use the Pythagorean theorem to solve for the distance. This happens to be a right angle up here because this is a rectangular coordinate plane. And we've got two sides of a right triangle, and we are interested in finding the third side. Most people are aware that this distance is 8 because I literally counted it, but I also found the distance using the subtraction. I subtracted the y coordinate, which was at 9, and this other y coordinate, which was at 1. And when I subtract those two, I get my 8. That's where this occurred. And I also have an x coordinate at 1 right here. And I have another x coordinate over here at 7. And the difference between these two is 6. I'm going to write it up here. Now, what we have now is a right triangle, and we know that a squared plus b squared equals c squared. And we can use the distance formula, which is literally a solved version of the Pythagorean theorem. So I'm going to go ahead and show you the Pythagorean theorem says for any right triangle, a squared plus b squared equals c squared. And here's my right triangle up here that you can see it right here. This is a right triangle. I just put a little bit of shading in there. I didn't want to make it too ugly here. This is a right triangle up here, and I may be interested in finding that missing side of that right triangle. So one of the legs is A, which is maybe, I'm going to go ahead and use the y values for that one. So that's going to be my 8. And B is my 6. That's another leg of my right triangle. And I'm interested in finding C. Well, in order to find C, I'm going to take 8 squared, which is 64, and 6 squared, which is 36, and that's going to be equal to C squared. And I get 100 is equal to C squared. Well, in order to solve that, I need to find the C that when I square it gives me 100. Well, that question is, what is the square root of C squared, which happens to be, C happens to be 10. And that is the distance between these two. So this distance is 10. Now, I have a distance between 2 points. The midpoint is halfway, isn't it? And if you are interested in the midpoint, it happens to be the average of the x's and the average of the y's. And in just a minute, I'm going to find the midpoint and prove it. But before we do that, let's go ahead and get rid of this. I'm going to erase this piece here, and I'm going to write it as the distance formula instead. And hopefully you're going to see that we have a connection. The distance formula is basically doing what we just did, but starting out with the answer more or less. The distance between 2 points is the square root. I'm going to write it this way, y2 minus y1 squared plus x2 minus x1 squared. Now, some people are going to see it written with the x's first instead of the y's. The reason that I write the y2 minus y1 first is because I want you to see the connection between the slope and the distance formula. And that's why I didn't reduce my slope, because I already know that y2 minus y1 is 9 minus 1, or 8. And there's my 8. Hopefully you can see the connection with what we did before. Plus x2 minus x1, which is right there. 7 minus 1 is 6. And there it is. And when I square both of those, I get the square root of 64 plus 36, which is the square root of 100, which of course is the distance is equal to 10. So hopefully you saw the connection between the distance formula and the Pythagorean theorem. We also have a picture of our distance. Now, I would love to be able to pick up that this line, and I'm hoping that it allows me to do that. So what I'm going to try to do is I'm going to try to pick up that line, and I want to show you something. I'm suggesting that this line is 10 units long. And I sometimes call this gum wrapper math, because what I tell the students to do is to grab a gum wrapper, measure along the two sides of your line segment between the 2 points and see if it actually gives you 10 units. So I'm going to try that right now. And I'm going to choose my segment. And I want to show you if it allows me to rotate it here. Oh, it let me move it, darn it. Well, there it is, 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's 10 units. What I'm going to try to do is not move its length and just simply keep it in the same space if it lets me. Oh, unfortunately. Hopefully you can see what I did there. This distance is literally 10 units, and I can literally measure it on my coordinate grid physically. So hopefully all that makes sense to you. And we're going to do one last thing, and I'm going to find the midpoint. The midpoint for these two is the average of the x's and the average of the y's. And I think I'm going to go ahead and put it right here. The midpoint for this, oh, darn it, go with that guy, is x1 plus x2 over 2 and y1. Oh, I'm running out of space. Okay, forget that. Sorry, guys. Let's see if I can just put the midpoint. I'm just going to add my two sides, add my two x's together and divide by 2. 1 plus 7 over 2 and 1 plus 9 over 2. What I did was average my x's and average my y's. And 1 plus 7 is 8 over 2 is 4. And 1 plus 9 over 2 is 10 over 2, which is 5. So I'm going to suggest that 4, 5 happens to be the midpoint on this graph. And I'm going to erase all of this for a second. And let me put my points back in, 1, 1. And I'm going to graph 4, 5. 1, 2, 3, 4. Now I'm suggesting that that's the midpoint. And I'm going to graph the point 7, 9. And I just want to show you something interesting. This midpoint certainly looks like it's in the middle. And 4, 5 certainly looks that way. But what I want you to notice is that if I count my slope, 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, that's 8 over 6, happens to be the same as up 1, 2, 3, 4 over 1, 2, 3, up 1, 2, 3, 4, and over 1, 2, 3. By the way, this distance is supposed to be 5, isn't it? Isn't that supposed to be halfway? Well, there happens to be a Pythagorean triple 3, 4, 5. And if you do the Pythagorean triple, you'll find it. So there's a lot of stuff going on there. And what I'd like you to try is the next problem yourself before we go on and move to the next problem. So try the next one, and it is right here. Here's our next problem, -5, 3, and 7, -2. Find the distance, the midpoint, and the slope for those two, and I'll see you back in part 2. Bye.